For decades, people believed the future of aircraft was simply about flying faster, carrying more passengers, and traveling farther than the generation before. Inside the quiet maintenance hangar behind the terminal, a young male engineer stared at the matte gray, narrow-body.
A young female engineer slowly reviewed technical data panels and understood that modern airlines were now facing problems that more
Hydraulic pressure holding steady at 3,000 psi. Confirmed. Data recorded.
Outside on the runway, aircraft continued taking off on schedule, but deep inside the aviation industry, the way engineers thought about the future had already begun to change.
In the past, every new generation of aircraft was promoted as faster, larger, or capable of flying farther. But as aviation became more advanced, engineers slowly realized that the skies of the future could not survive by endlessly increasing power and size. Amid the steady hum of ventilation systems inside the maintenance facility, the young engineer began asking a question the entire aviation industry was quietly confronting. If future aircraft cannot simply become faster and larger, then what truly needs to change for aviation to remain sustainable for decades to come? That question did not begin inside marketing departments, but inside engineering hangars, where people could see the true limitations of modern flight with their own eyes. Under normal operating conditions, every commercial aircraft is designed to maximize efficiency, stability, and continuous operation across demanding schedules. The young engineers inside the hangar understood that even a small delay in inspection could disrupt an entire chain of flights for hours. Check the sensor array on bus 3. The readings are still fluctuating.
I see it. Looks like a loose connection right here. Most of modern aviation was no longer about making aircraft fly faster, but about keeping them reliable every single day.
In aviation, reliability has always mattered more than spectacle, because a slower aircraft that operates Airlines also began realizing that fuel costs, maintenance pressure, noise restrictions, and environmental concerns were becoming greater challenges than the old race for speed. For many years, people imagined the future of aviation as giant supersonic aircraft crossing continents in only a few hours. But real-world operations proved that the larger and more extreme systems became, the harder they were to maintain, optimize. That was when many engineers began changing the way they imagined the aircraft of the future. The conflict became clear when manufacturers pushed for revolutionary technologies, while airlines desperately needed simplicity and operational stability.
The young male engineer studied simulation screens and realized that higher speed always meant higher temperatures, greater stress, and massive energy consumption.
The young female engineer analyzed maintenance records and discovered that the more complicated aircraft systems became, the aviation industry slowly confronted a difficult truth that not every technological breakthrough actually improves real-world flight operations.
An aircraft could appear revolutionary on paper, while becoming a maintenance nightmare once it entered daily airline service.
Engineers also understood that the future of aviation was no longer only about passenger experience, but about the long-term survival of the entire operational ecosystem. Inside the quiet maintenance hangar, the conflict between technological ambition and engineering reality became more visible with every new aircraft design. Future aircraft needed to become smarter, but if that intelligence made systems harder to manage, it would simply create new risks. That was the moment engineers realized the real transformation was not about speed or size, but about the philosophy behind aircraft design itself. The root cause began with the fact that the operational environment of modern aviation had completely changed from what it was decades ago. Today, the skies are more crowded, safety expectations are higher, environmental pressure is stronger, and operational schedules are far more demanding. The young engineer looked at overloaded maintenance schedules and understood that the future of aviation depended on reducing pressure on humans rather than constantly adding more complexity.
That is why manufacturers began investing heavily in self-checking systems, predictive maintenance, and real-time data analysis. The young female engineer explained that the ideal future aircraft would not be the fastest one, but the one capable of detecting risks before failures even occurred.
The young workers no longer relied only on mechanical tools, but also monitored thousands of sensor signals continuously flowing through the aircraft systems. In the future, structural materials themselves would also need to evolve, becoming lighter and stronger and even. The aviation industry was also being forced to think about sustainability, because aircraft consuming massive amounts of fuel.
Speed once symbolized the future, but now long-term operational efficiency is what truly defines the value of an aircraft.
Engineers understood that tomorrow's ideal aircraft must reduce human error, lower maintenance costs, and minimize energy consumption all at the same time. That is why the biggest transformation of future aircraft will not be visible from the outside, but hidden in the way the aircraft thinks and supports the systems around it. Compared to the old mindset, aviation once resembled an endless competition for power and speed between nations and manufacturers.
The new philosophy instead focuses on resilience, adaptability, and the long-term stability of the global aviation network.
Sitchinwitz. The young engineer realized that an aircraft designed for easier maintenance is often far more valuable than a highly advanced aircraft that...
The young female engineer also understood that the future of aviation belongs to systems designed to support humans instead of forcing humans to control everything manually.
The young workers continued operating beneath the matte gray aircraft, as proof that future technology will always depend on practical daily operations. Future aircraft may become quieter rather than simply faster, smarter rather than simply larger, and more efficient rather than simply more powerful. The aviation industry is slowly shifting away from the idea of conquering the skies and moving toward maintaining the long... That shift is why many concepts once considered futuristic now appear outdated, because they no longer match operational reality.
An aircraft that consumes too much energy or becomes too difficult to maintain cannot survive long-term, no matter how impressive its technology may seem.
Beneath the cold white lights of the maintenance hangar, the young engineers began viewing the future through a far more practical lens than previous generations ever did. They no longer asked how fast an aircraft could fly, but how long it could operate reliably without creating pressure on people or the environment.
In the end, the future of aviation will no longer be defined by maximum speed or enormous size like the old dreams of the industry once imagined.
The true future will be defined by intelligent, stable, sustainable, and manageable flight systems.
Units. The young engineer quietly looked across the line of aircraft undergoing maintenance and realized that the biggest transformations options. The young Caucasian female engineer closed the final maintenance and understood that the aircraft of the future would resemble an adaptive ecosystem.
The young workers continued their duties inside the silent and disciplined facility, as if the future of aviation was always...
Humanity once believed progress meant moving faster than everyone else. But modern aviation is proving that true progress means operating...
That is why future aircraft must evolve beyond speed and size, because the skies of tomorrow will not belong to the most...
That is why future aircraft must evolve beyond speed and size, because the skies of tomorrow will not belong to the most powerful aircraft.